To give you a better understanding of biasing and amplification, let us look at an example. Consider a transistor with this characteristic. It applies for Vi is greater than equal to 0 volts and V0 is greater than or equal to 0.3 volts. You are to find the limits L minus and L plus and the corresponding values of Vi. Also find the value of the DC bias voltage Vi that results in V0 is equal to 5 volts, and also the voltage gain at the corresponding operating point. Let's look at how we can solve the first part about the limits. L minus is obviously 0.3 volts. These limits are for y-axis, remember, and V0 is the y-axis. The corresponding instantaneous input voltage value is obtained by putting V0 equals 0.3 volt into this equation to get Vi equals 0.69 volts. To find L positive, we put Vi equals 0. Into this equation again. Why? Because in order to find limits, we have to go look at the extremes. Putting this value into the equation gives the value of L positive to be almost 10 volts. Notice that L positive and L minus are both values of V0. Now, next part of the question. It asks us to find the Q point or the DC bias point Vi. To do this, we put V0, the DC output voltage, equal to the instantaneous V0, that is 5 volts. Putting this value into this equation gives us Vi equals to 0.673 volts. To find gain, we take the derivative and put Vi, that is 0.673, and we get minus 200 volts per volt. So our amplifier is an inverting one with the output 180 degrees out of phase with the input. Here on the top right is a sketch of the amplifier transfer characteristic. We again note that the amplifier is inverting.